Alright, so three concepts now. Duration matching, key rate durations, use of key rate duration to align the risk exposures of the portfolio with those of benchmark index. First point, duration. Effective duration, which we also call as option adjusted duration, which is used to estimate the change in the value of portfolio given small parallel shift in the yield curve. Okay, so these are the two words that you need to know. Duration works well when the changes are small in the yields and also the changes are parallel. Most obvious risk factor to be measured. Due to linear nature of duration, we know that the actual increase in the bond price is always more and the decrease in the bond price is less because it is convex toward the origin. So convexity is also to be considered. Are we fine with this? Key rate duration measures the portfolio's sensitivity to twist in the yield curve. Do you agree? Javed, twist means a non-parallel shift, right? Either steepening or flattening. So for every maturity, the yield has changed by different amount, but we have a key rate duration, so it will tell us by how much the portfolio value will change. Due to nearly endless combination of assets that will have the same duration as the index, manager must also ensure that portfolio also matches index exposure to important key rates. This sentence is really important because you might get a question on the exam, something like this. One manager makes a comment saying that I have ensured that portfolio's duration matches the index duration. Okay. And therefore, effectively, the risk exposure is exactly same. And then you would be required to explain agree or disagree, and the answer would be disagree, because he should not only manage duration, but he should also ensure that at least the important key rate durations are same. Are you following this? So duration should be same, also the key rate duration should be same. Mismatches can occur when the portfolio and the benchmark contain different combination of bonds with varying maturities and key rate durations, but overall effective duration. Understood this point? That means this is your index. Index duration is 5. You build a portfolio. The portfolio duration is also 5. Okay, so you've been able to match duration, but the constituents and the key rate duration that you've not been able to match. And if the key rate durations are not going to match, then it's a classic case of mismatch. Should I repeat this again? Yes, no? Yes, no? Mismatches can occur when portfolio and benchmark contain different combination of bonds with different maturities and different key rate durations, but the overall effective duration is same. Two bonds have same effective duration, but the constituent key rate durations are different, maturity is different, it's a mismatch. Is it fine? Alright, so risk profiling of an index requires measuring index exposure to various factors like duration, key rate duration, present value distribution of cash flows. What is this? Similar to Macaulay's duration. This is actually the second technique of calculating portfolio duration, PVD. See, I will try not to confuse, just stick to point. Present value distribution of cash flows, it's called as PVD. Let us say you have 3 bonds in your portfolio, bond 1, bond 2 and bond 3. Okay, let me call them rather as bond A, bond B and bond C. This has a maturity of 3 years, this has a maturity of 5 years, this has a maturity of, let's say, 10 years. Let us say the coupon rate of this is 10%, 15%, 20%. This example you need not write. And they have face values of 1000. What we want to do is, we want to calculate present value distribution for this particular bond. Now, do you agree that any coupon bond is nothing but a combination of zero coupon bond? We've understood the process of stripping in the previous session. So any coupon bond is nothing but a combination of various zero coupon bonds. Do you also agree that a zero coupon bonds Macaulay's duration is same as its maturity? Yes, so if a zero coupon bond has a maturity of 1 year, its Macaulay's duration is also 1 year. Now make a distribution like this: year 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now what are the cash flows that we expecting to receive at year 1? We will receive 100 from the first bond, 150 from the second one and 200 from the third one. Now some present value of these cash flows is contributing towards the value of that bond today, value of the entire portfolio. Are you following what I'm saying? In the same fashion, we will have, so in year 4 we will have only 150 and 200, and then year 7 onwards or 6 onwards we will have only 200. So now calculate the weight of present value of these amounts, the weight of total portfolio. Instead of calculating the weight of the individual bond, now think of it this way, that we have about 50-60 zero coupon bonds. Okay, the first bond has maturity of 1 year. These are the face values of those bonds. We will take present value of these, and present value of this 3 zero coupon bonds into 1 would be the present value distribution of this bond here. Then present value of these cash flows today into 2 would be the present value distribution. In this case, make a total of all the PVDs, and then that's the duration of the entire bond. But now what we have done, have you understood this? Sure. Now what we have done is, we have been able to find out that which maturity is contributing to your duration how much. Following this, that 1 year maturity is contributing to duration how much, 2 year maturity is how much, 3 year, and then when you build a portfolio and when you want to match the risk characteristics, also try to match PVDs of them. Clear? Do you want me to explain this again? Let's calculate PVDs for a bond. Let's experiment, let's see how it works. We'll keep example relatively simple. Let's say we have bond A, which has coupon rate of, and we'll keep it annual now, coupon rate of 10%. Bond V, coupon rate of 15%. Let us say the maturity of the first bond is 3 years and maturity of the second bond is 5 years. Let us say that YTM that we are going to use, okay, I'm making a hypothetical scenario, is 10%. We want to calculate present value distribution of the bond. Okay. So what are the cash flows are we looking at? This is time 0, this is time 1, time 2, time 3, time 4 and time 5. The cash flow we will receive at time 1 would be 100 and 150, time 2 100 and 150, time 3 100, 150 and 1000, assuming 1000 is the face value, time 4 150, time 5 150 and 1000. Is it clear? Let us calculate present value of each of these amounts, not the total but the present value. Okay, so present value at time 0. So second clear TVM, 250 future value, 250 future value, 10 IY, 1N compute present value, 227. Now just make 2 as N, make 2 as N and compute future value, present value. How much? 206. Now make 1250 as future value, 1250 as future value, 3 is N, 10 is IY, compute present value, 990, 939. 150 as future value, 4 is N, 10 is IY, 102. And 1050 as future value, 5 as N, 10 as IY. 714. Now what would be the value of your portfolio today? Take total of the entire amount. Total of the entire amount is 2189. Okay. Now out of that 2189 value of the portfolio, how much proportion is coming to you at year 1? So this value weight would be 227 divided by 2189. Can you tell me how much? So this is 10.37%. 206 divided by 2189. 9.41%. 939 divided by 2189. 42.8%. 102 divided by 2189. 4.65. And then 100 minus all these numbers, so that we get a round figure. How much? 32.61. Okay. So assuming that the total comes to 100 or close to 100%. So this is your distribution of those present values. Correct? And what are these? So think of it this way, that we have purchased one zero coupon bond today for 227. In 1 year it will give us 250. We have also purchased one zero coupon bond today for 206. In 2 years it will give us 250. We have purchased one zero coupon bond today for 939. In 3 years it would give us 1250, so on and so forth. And zero coupon bond, we know duration is same as maturity. So then 1 into 10 so this is now your present value distribution. 1 into 10.37, so that's 0.1037. 2 into 9.41, so that would be 1.882. Is it? 2 into 9.41%. 2 into 9.41%. How much? 1.882. 0.182. Yes. Then 3 into 42.8%. 3 into 42.8%. 3 into 42.8%. 1.284. 4 into 4.65%. 0.186. And 5 into 32.6%. 1.6305. Now take a total of all the numbers. .28. Okay, 3 point. Okay, let me just keep it as 30. Okay, somewhere close to that. So the duration of your portfolio is 3.30. But present value distribution is stronger than key rate duration, because key rate duration was bond specific. 3-year, 5-year, 10-year bond. Now this is available for every maturity, and therefore you can manage the risk factors even in a better fashion. In this case we have two bonds, one with maturity of 3 years, one with maturity of 5 years. Right, we will have YTMs now for a 3-year YTM and a 5-year YTM. In this case both of them are 10%. Now if YTM changes for the 3rd year, key rate duration tells us how much this bond will contribute to the change in bond price. But what if only the 1st year spot rate change and nothing else changes? Hypothetical. Of course, change in the first spot year will change all the spot rates. But if you know the change in the 1st year spot rate, using the PVD, we can find out the exact change in the portfolio of the bond. Because YTM is an average of all the spot rates. Are you following this? A YTM is nothing but a complex mathematical average of all the spot rates. Imagine a scenario that only the 1st year spot rate has changed. Okay, that will have some impact on 3-year YTM, some impact on 5-year YTM. So we can still find out what would be the change on value of portfolio. But in this case, if the 1st year spot rate has changed, we know that what is the contribution of duration by the 1st year spot rate. Following this? Contribution to the duration for 1st year maturity. So using this PVD system, we can do a stronger risk alignment so that no matter what maturity rate changes, your risk exposures is same with the index and the portfolio. Yes, no? Or huh? Huh? Yes, it will. See, it's like this. Uh, I'll try not to make this complicated. A 3-year key rate duration is actually a 3-year coupon portfolio. See, what was key rate duration? We said that instead of having a portfolio duration, let's have contribution of third year bond separately, contribution of 5-year bond separately. But what is a 3-year bond? It's actually 3 separate coupon, 0 coupon bonds. What is a 5-year bond? It's 5 separate 0 coupon bond. So in a PVD system, you're going one step below. Now you're finding out what is the duration contribution of the first year 0 coupon bond, duration contribution of the second year 0 coupon bond, and therefore you can manage your risk exposures in a better fashion. Still not clear? Clear? So that was applicable even in key rate duration everywhere. No, everything would, if you add a new portfolio in the key rate duration system, weights will change. And therefore again, all the key rates are going to change automatically. In the same fashion, if you add a new portfolio, cash flows will change. And again, the entire PBT will change. That is true in both the cases. See, this is happening to you because do you remember the process of stripping? Right, that we can take a coupon bond and we know that each coupon bond is made of multiple 0 coupon bonds. So now there are two ways in which you can look at duration. One is a portfolio duration. Portfolio duration says if all the yield change, then if all the yields are going to change, then the portfolio value will change by this much. We said no, there can be a twist, isn't it? 3-year and 5-year can change differently. But now we are going one step further. We are saying this is not a 3-year bond. We have about 10-15 separate bonds, or in this case 5 and 3, 8 separate bonds, and these are 0 coupon bonds, and in fact 5 0 coupon bonds. Why they are more? Because this is a separate 0 coupon bond, this is separate. But let's assume that this is a 1-0 coupon bond. Now what if only the interest rate of year 1 change and nothing else changes? Then we know how much is that going to affect the value of the bond portfolio. Now spot rate of year 1 changes, YTM of year 3 will also change, YTM of year 5 will also change, and therefore we will, using this method also, we will be able to find out. But then this is giving us a more stronger relationship, and we know what is our exposure to year 1, which we did not know in case of key rate durations. Followed? Are you done writing this? Should we go ahead then? Okay. Next one is sector and quality percent matching weights. That means different sectors, the weight in your portfolio and the weight in the index should be same. Different quality, AAA, AA, the weight in the index, weight in the portfolio should be same. Sector duration contributions. The duration which is contributed to your portfolio by RMBS sector, residential mortgage backed security, and the duration of your portfolio through RMBS, even you should try to manage that. Then quality spread duration. Spread duration means we've learned the concept of duration. We can calculate a duration for a spread as well. What are spreads? The difference between yield on a government bond and yield on a risky bond. So we know that there could either be a G spread, also called as nominal spread, correct? Or there could also be a Z spread, or there could also be a option adjusted spread. So meaning of a spread duration is that if spread changes by 1%, then what impact will that have on the value of bond? As against a duration which says yield changes by 1%, what impact will that have on value of the bond? Following this, so you not only try to match duration, you also try to match spread durations. Then again, which sector, what coupon, what maturity, sell weightings, and issuers exposure to event, which means if you try to use a sampling method and you purchase too much of bond from a single issuer, though it's representative of the entire index, what if something goes wrong to the issuer, right? So don't have too much of exposure to a particular event as well. So when you take care of all of these, then you have done a good quality sampling. Is that okay? Now write down all the points. So you wouldn't get management fee of cost. It's good for us, we'll get jobs. Alright, so let's move on further. Now a sweet summary of what are different risks, what are they affected by, and what measures are used. We have an interest rate risk, which is typically affected by shift in the yield curve. Measures used is duration. Yield curve risk affected by twist in the yield curve. Measure used is key rate duration and also PVD. PVD is present value distributions. Spread impact is spread changes, and it can be managed by matching spread durations. Durations built specific to factor in the spreads. Credit exposure to changes in credit quality. It can again be matched using spread duration. Optionality exposure to call or put, and this is typically measured using deltas. Should we move on? This you need not write. This is available in your notes. Okay. Please answer. B? No. Yeah, I couldn't think of an option. I thought. Okay, next one. A. Enhance indexing by matching primary risk factors. Is it the first method or second or third or fourth or fifth? Second one. Second one was what? Sampling. So what is the answer? A sample of bonds to match the primary index risk factors with the goal of minimizing construction and maintenance cost. Fine. Enhanced indexing by small risk factor mismatches. Is it passive or active? Passive. Which one? Third one. Yes. Not necessary that you are taking undervalued, you're picking up undervalued bonds. Match duration while allowing the manager to tilt the portfolio in favor of other risk factors. Okay. Next LOS now. Use of total return analysis and scenario analysis to assess the risk and return characteristics of the proposed trade and learn supporting calculations. So the LOS command word is demonstrate. Okay, and whenever the command word is demonstrate, we have to also learn the supporting calculations. And this is nothing but a LOS which is focused on scenario analysis. Okay, so we'll do one example for calculations here. Now I'm sure you know what scenario analysis is. We have base case, worst case or base case scenario, where at one point you change all the assumptions. It allows portfolio manager to assess portfolio total return under varying set of assumptions, different scenarios. Important word here, possible scenarios would include simultaneous assumptions regarding interest rate spread at the end of the investment horizon, as well as reinvestment rates over the investment horizon. What is this? Let us say there is a bond which has got face value of 1000. Okay, hypothetical, coupon rate of 10%, maturity of 7 years, and let's assume that reinvestment of coupon can be done at the rate of 8%. This is the data. You intend to hold that bond for a period of 3 years. Now which things can go wrong in 3 years? One, the yield might change. Correct? Yield might increase or decrease, or the rate at which you can reinvest, that might change, both directions, or the credit quality will change and therefore the spread will change. And now maybe all of these things will change together, either in the either direction. So doing either you do a simulation or you do a scenario analysis to find out what would be the total return earned. Is it fine? Estimating expected total return under a single set of assumptions or predictions only provides a point estimate of the expected return. A point estimate means currently the YTM is 8. You ask yourself, what if it is 9? Then what will happen to the return on bond portfolio? You will get one number, and this is kind of a point estimate. It's only one value. However, if you create multiple scenarios, you will get a point estimate, but you'll also get a probability distribution around it. Are you following what I'm saying? You can keep on changing assumptions and keep on generating different total return values. Combining total return analysis with scenario analysis allows the analyst to assess not only return but also the volatility or distribution under different scenarios. Yes, sensitivity analysis. So expected total return method is similar to sensitivity, where you change one variable at a time, right? But if you allow multiple variables to be changed in multiple directions, then you will have a multiple set of values with you. Okay, and then that is going to create a probability distribution. Scenario analysis can also be broken down into return due to price change, coupons received, and the interest on the coupon. Right, so again we can have multiple scenarios. What if the coupon received or maybe interest on coupon received changes? So we can build multiple distribution. We'll do one example just to be clear. Let's say we have a 7-year bond face value 1000, 8% semi-annual coupon, which can be reinvested at 6%. Calculate EAY and BEY. EAY is effective annual yield and BEY is bond equivalent yield. If yield changes to 7%, in fact we'll create a scenario, 7%, 6%, 8%, 9%, 4 scenarios, and investment horizon is 1 year. Can you do that? Do it for 1 year at least. That if yield changes to 7%, what will be the impact on EAY? What will be the impact on BEY? Bond equivalent yield, effective annual yield. I'm sure you might not remember bond equivalent yield. Bond equivalent yield is YTM into 2. 6-month YTM into 2. And effective annual yield is 1 plus 6-month YTM raised to 2. In iPhone you can get an emulator app. If you have an Apple phone, you can get an app which works exactly like your calculator. The Texas Instrument app, it's about $20. But there are also cheaper ones which are similar. But yeah, but now you try to, don't do it now. Calculate this first. Alright, I'm solving this. Or you want me to solve this? Let's find out the current price of the bond. Current price of the bond. Second clear TVM, 1000 future value, 40 payment, 14N, and 3.5, no. What is the current IY given here? Which can be, if the yield changes 7%, investment horizon is 1 year. No, we don't have a current YTM on this. Let's assume that to be same as the coupon rate. The current YTM is not available to value the bond. So let's assume that to be same as coupon rate. So 4 is your IY, compute present value. How much? 1000. So you purchase a bond for 1000. You intend to sell that in 1 year's time. Okay. Now, if the yield is also same in 1 year, so current YTM is 8%. If the yield is also same in 1 year's time, bond value would be how much? 1000 itself. If coupon rate and YTM is same, bond value would be 1000. So after 1 year, you'll get a cash flow of 1000. Plus what you'll get is coupon plus reinvestment income. Isn't it? You must have received 2 coupons so far. And at what rate you've been able to reinvest that? 6%. So second clear TVM, 40 payment, 2N, 3 IY, 2N, Javed, why 2N? Why 2 as N? Because we will receive 2 coupons in a year. And 3 IY, compute future value. 81.2. So total amount of cash that you have by the end of the year is 1081.2. The first thing that we calculate is what is the effective annual yield that we are going to earn on this type of bond. To calculate effective annual yield, step number 1 is simply to calculate a 6-month yield. Okay, so we'll in fact try to calculate both. We will try to calculate EAY and we will try to calculate bond equivalent yield. So now let's do it together. Second clear TVM, negative 1000 present value, negative 1000 present value, 1081.2 future value, 1081.2 future value, 2 is N, compute IY. How much is that? 7.91. Are you sure it's 7.91? Have you kept 2 as N? Yeah, 3.99%. Yeah, this seems logical. Let's do it again, Vikram. Second clear TVM, 1000 present value. You might have not done second clear TVM earlier. 1000 present value, 1081.2 negative future value, 2 is N, compute IY. How much? 3.99. Effective annual yield, 1 plus 3. In this case we could have done it directly, but just to show you calculation, 1 plus 3.99% raised to 2. Okay, so do it with me. 3.99% plus 1 x square. It would be slightly higher than 8.13%. Now to do this, we are kind of in a way doing it stupidly, because if you just would have kept 1 as N, you would have got the same value directly. Just experiment. Say 1 as N on your calculator, compute IY. Is it same? Yes, because what we did, we said 2 as N, calculate 6-month yield and compound it twice again. Just to learn that for longer maturity is how we are going to do it. What would be bond equivalent yield? It would be 3.99 into 2. So that's going to be 7.98. Okay, this is your first scenario. Now we can build one more scenario. What if when you sell the bond, the YTM has changed to 9%? Okay, so once this is changed to 9%, this value will change and you will have some other value here. Are you following what I'm saying? When you're selling your bond in 1 year from now, the YTM has changed to 9%. Then it will not be 1000, it would be slightly less than that. Plus we will have coupon plus reinvestment income. So we will be able to calculate EAY, BEY. What if it is 10%? Again we'll have different scenario. This is your one type of scenario analysis. We can also change reinvestment income and then we can build multiple scenarios. Or we can change both of them together. Is it okay? Should we go ahead then? Yes, no? Bond immunization strategy to ensure funding a predetermined liability. Evaluate strategy under various interest rate scenario. Okay, we will do only the first part of this LOS today. And the first part of the LOS is called classical immunization. When we did some background building on fixed income, we had covered this once, but we will do it again. Classical immunization, or what is immunization in a way? You have a liability to be taken care of 5 years from now. You have some amount of cash flow. How do I invest my cash flow into a bond in such a way that no matter what happens to the interest rate in the market, increase or decrease, the amount that I will receive on the date of liability has to be exactly same. I want to completely immunize myself against the changes in interest rate. That is a classical immunization. Now interest rate will pose you two types of risk. What two types of risk? One is market price risk and second is the reinvestment risk. Correct? Now imagine a scenario that interest rate increases. Okay, then bond value here will decrease, but your reinvestment income here will increase. If you're holding bond for a very long period, reinvestment income increase would be higher than bond value decrease. Following why? Because that increased interest rate will discount only less number of periods, but reinvestment income you would get for a longer period. If interest rate decrease, now the bond value will increase and reinvestment income will decrease. Imagine a scenario that if you're holding your bond for a short period, now you will have a benefit of market price, and reinvestment anyways won't affect much because you're holding it for a shorter duration. How do you hold that bond in such a way that this market price risk and reinvestment risk will automatically offset each other no matter what happens to the interest rate? Is called as the classical immunization system. And the trick is that when you're dealing with a regular bond, a straight bond, simply hold the bond till its Macaulay's duration. And if you're holding some option embedded bonds, the way it's given in your syllabus, then you hold the bond till its effective duration. So effective duration of a bond is 5, maturity is 7. You hold that bond for 5 years. If you sell the bond exactly in the 5th year, reinvestment risk and market risk would have offsetted each other, and therefore the YTM earned on the bond would be what you originally wanted it to be. Is it fine? So write down this part. We'll do some further analysis on this. Should we go ahead? Let's read the procedure of how it is to be effective. Select a bond with an effective duration equal to the duration of the liability, which means you have a liability which is to be repaid in 6 years. Then search the bond which has got effective duration of 6 years. Step number 2, set the present value of the bond equal to the present value of the liability, which means how much bond should you purchase, that should be equal to present value of liability. For example, you have a liability of 500 crores or let's say 500 million 7 years from now. Step number 1, go in the market, find out those bonds which have effective duration of 7 years. Okay, not the maturity of 7 years, those bonds which have effective duration of 7 years. Step number 2, find out what is the YTM on those bonds. Let's say a YTM hypothetical of current YTM of 20%. Okay. So take present value of 500 million, 20%. Let's say that's coming out to be, let's do it, how much? 500 future value, 7N, 20 IY, compute present value. How much? 139. So purchase bonds worth 139.5. Now, if you've done this, what will happen is, irrespective of by how much interest rate changes, your yield earned is going to be 20%. Right? Because the duration of holding the bond is similar to its effective duration. And if the yield earned is 20%, then you will have 500 million, pay off your liability. However, the catch is, the last point, classical immunization works only for one time instantaneous change in the interest rate. So interest rate changed and you had one, if it changed only once, you are fine. But if it changed multiple times, that change in the interest rate multiple times will change the duration, and therefore you will have to constantly keep on rebalancing your portfolio. So if you do not rebalance your portfolio and if the interest rates keep on changing, classical immunization is not going to work. Are we fine?